Hi, welcome back to my shed. For these fire break lessons, we're going to be working from Theme 4 Part 2. That's the dark green booklet that you were given just before the fire break. This second part of Theme 4 is looking at how we actually use sedimentary rocks, how we turn them into something beyond just a subject for interesting study and into something that's actually really important for our world. Perhaps the most important role sedimentary rocks play is as a store for fluids of different kinds. Whether that be water, oil, or gas, we rely on being able to find and extract these fluids from the rocks. Anyway, we're starting a new booklet, so as ever, I'd like to turn to the inside the back page and have a go at what's in a word. Press pause now and have a go at that. Okay, we're going to start by looking at water. It's a crucial part of geology and one that employs a lot of professional geologists. Now, as geologists, we're really interested in the part of the water cycle that happens in between water hitting the ground as some form of rainfall and then getting into the sea. And in particular, where that rainfall percolates down through the soil, down into the bedrock. When it gets there, it can flow, just as water on the surface can flow, and also can be stored there and can be a vital source of water supply. Now, for this to happen, there has to be some space within a rock for water to be stored. We call this porosity. You should have watched the introductory video by now to find out a bit more about what porosity is. But porosity on its own is of limited use. For us to be able to use these rocks, we also need to have fluids like water being able to get into the rock, and we need to be able to get it out of the rock so we can use it. For that, we need a property called permeability. Permeability is where we have these spaces within a rock that are connected to each other, so these fluids can actually flow. Let me show you what I mean by looking at an example of chalk. These are the rocks that we're looking at in today's lesson. We've got a collection of different types here. But remember, we're starting to think about using these rocks to store fluids. Let's start by looking at this. This is chalk. Very obvious to identify this one. Pure white, and as you can see from my fingers, it's really quite soft as well. This rock, as we've already learned, is made of the shells of tiny little organisms called alkalids. Now, one of the features of chalk is its porosity and its permeability. If we do a little experiment here, let's take some water and just pour a little bit on top of the specimen. We're not going to have to wait very long for this water to soak into the rock. You can see the water starts to disappear into it. As the water flows through the gaps between the little shells into the pores and starts to fill the rock up. If we look at it from the side, we can see the water starting to fill the gaps within the rock. And very quickly, the water disappears. So this rock is porous because there are gaps between those shells, and it's permeable because those gaps are actually connected to each other. So a liquid could actually flow through that rock. It's why a large part of the southeast of England will store the water it needs in rock like this. For this lesson, we're going to have a look at 5 different types of rock. These rocks are conglomerate, granite, desert sandstone, shale, and oolitic limestone. We were introduced to these in the previous part of theme 4. But what I want us to do is to be able to look at the texture of these rocks, the grains, how they fit together, the size, the shape, the sorting of any grains in there. Watch this video to see some description. Now we're looking at these 5 rocks. If we start with this one, this is conglomerate. We can see the range of grain sizes in here. We can see the shapes of those clasts within this rock. And we can perhaps get a hint that there might be some gaps between those clasts. The second rock is very different. This is an igneous rock. It's a granite. Now we learned earlier in the course that igneous rocks, like this granite, are made of random interlocking crystals. So really we shouldn't find any gaps between the crystals in these rocks at all. Our next rock, specimen Q, is this. This is a desert sandstone. Very distinctive red colour. Little flecks of white feldspar in there as well. It's not a particularly hard rock, this. I can break little bits of it off. So we know it's very poorly cemented. Grain size, you can see, is fairly even. There's a high chance of that rock being porous. Our fourth rock is this one. This is shale. Very fine grained. Even with a microscope we're going to struggle to see grains within this. You can see they're pretty well packed together. The rock itself isn't particularly hard. There's going to be a limited amount of pore space within this rock. Our final rock, specimen M, is this. At first glance, this would look like a clastic sediment with rounded grains, but this will fizz with acid. This rock is an oolitic limestone. It's a chemical sediment where these little balls of calcite have grown as they're moved around in the waves of a shallow tropical sea. Because of those rounded grains, there may well be some gaps, maybe some pores in this, although it is relatively well cemented. Okay, having watched that part of the video, I'd now like you to try and describe each of the rocks, and particularly their texture, on page 3 of your booklet. On your email, you'll find a PDF of photographs of each of those specimens that may help you. Press pause now and have a go at that. Okay, having described those rocks, let's think about how they might affect porosity and permeability. Watch this video where I test a few of these specimens to see if there is any porosity or permeability in them. Okay, so let's test some of these specimens to see what their permeability might be. Let's start with the granite. Remember, this is an igneous rock. What would you expect its permeability to be? Pour a little bit of water in there. You'll see that the water really isn't moving anywhere. I could make a very long and very boring video waiting for this water to just evaporate off the surface, because it's not going to run into the rock. This rock is not porous and impermeable. If we're thinking about porosity and permeability, we need to be looking at sedimentary rocks, because it's sediments with the gaps between the clasts that will allow fluids to enter the rock, move through the rock, and be stored within the rock. Let's have a look at the conglomerate. Pour a little bit of water onto this. And you'll be able to see relatively slowly this water is being absorbed into the rock. It's flowing into the pore space left between the clasts in this rock. Now, it's not particularly fast, this. Perhaps we need to think about how the texture of this rock, how the grain size, the grain shape, the grain sorting, especially the sorting, might be influencing the porosity and permeability. You can see the water there is being absorbed. The last of these I want to look at is this. This is the red sandstone. Remember, we've already seen that this rock is fairly poorly cemented. Right, let's try and pour some water onto the top of this. And we'll see, if we just wait a few moments, that water's starting to disappear. The water's flowing relatively quickly into the rock. And you can see the water disappearing. Clearly this rock has got to have porosity and permeability. What is it about the texture of this rock, do you think? Again, the size, the shape, the sorting of the grains within this that allows the water, as we can see, to be absorbed into it. Okay, so we now have an idea of the nature of some of these rocks. What I want to do next time is to actually work out how much porosity there might be. I'll see you then.